My name is Mohamed Omar. I am from Egypt. My background is architecture, and today I'm giving you the outline of my thesis conducted here in Ljubljana University. And the title is Automated BIM-based Model Checking Workflows with Exchange Information Requirements. So going directly to the introduction, just to give you an overview about the topic and which like the motivation for me to do this topic. So as you know, model checking processes is time consuming, effort consuming. If you are doing this in 2D, it will be very hard. Even if you are doing this through the BIM, it is also time consuming. And during my previous work, it was something like very critical for me to do this. And that's why it was a motivation for me to try to automate somehow this process and to develop different workflows. And like for this research, I have main aims and objectives. Like the first one was to explore different BIM uses, mainly the code validation, clash detection, and quantity takeoff and cost estimation. And then I can, based on this information requirements, I can develop specific workflows for the BIM-based model checking, or as I'm calling BMC, and then we can define specific checks. We can define specific checking scenarios for the information requirement. And then using those workflows and those scenarios, we can implement it on a real case study just to know the limitation and opportunities for each workflow. So traditionally for the BMC workflow, for the BMC process, it has four main stages or functionalities of rule interpretation and model preparation and rule execution and then reporting. And during this research, I suggested to add two main stages. The first one will work as an input to use the level of information need framework as an input for the rule interpretation part. And the last stage will also be added to automate somehow the results, because usually in most of the software, you are just getting ID and results and you cannot manipulate with these results. And my suggestion is to develop somehow like some codes to automate this process. So I suggested like 3 workflows during this research. The first one is done totally inside the repository. I use here the Autodesk repository Revit. And the idea is to use the Revit interoperability tools. They have several rules. You can use the model configurator for the rule interpretation part, and even using XML editor for developing these rules. And for the model preparation, as I said, like we will use Revit, and then using another tool to run these checks, we can get the results, and then using Dynamo or Python, we can manipulate the results and going back again to the model stage to close the loop. The second workflow is to use a standalone software that is designated for this kind of checks, which has more functionalities. And here we are talking about several options in the market. We can say like BIM Collab, Pixel, Solipri, whatever you are using. And here we are talking about using the building smart formats in the exchanging. So we can use the IFC. So in the model preparation, the model is prepared in the Revit, and then you can exchanging using IFC to the standalone software, and the rest of the process will be done inside this software, including the rule interpretation and rule execution. And then once you have the results, you can go back again to the repository using the BCF, which is one of the building smart formats, or you can use Excel and then using some Dynamo codes and take it back to the model stage to automate the solution. The third workflow is using OpenBIM formats totally, and the difference between this workflow and the previous one, that all the process is done using the OpenBIM formats. So the rule interpretation part is done through the IDS. And here we are not limited to any kind of software. You can use any software you want just to run the IDS or to compile the IDS against the IFC, and then you can results, and the same, you can take it back to the repository. Parallel to this, I developed also those scenarios just to highlight the main scenarios for the information requirements. The first one is to check the property existence and the value, and it has 5 stages of first to check if the property or the parameter is existed or no, and then you check if it is in the right property set. And the third stage is to check the data type, whether it is text or Boolean or numeric, whatever. And the fourth stage is to check if this property has a value or no value, and the fifth is to check if this value is correct or not. And mainly for this part, we will use the regular expression, which I'm going to explain later. The second scenario is to check if you have a duplicated element or no, in terms of geometry, and the third is to check if you have a duplicated property or not. So here we are just talking about duplication and how we can manipulate with this duplication, whether you delete someone or to rename in terms of information, or if we are talking about geometry, how we can deal with this, which is like the best approach to delete it or to report it. So going directly to the case study, it was developed with Protein. It is a Slovenian design company here, and the idea, as I said in the beginning, is to implement the workflows and scenarios against a real case study, just to know the limitation and opportunities in each workflow. So the first stage here in this case study was to define the level of information need and the textual rules that we are going to implement. So the company already has some rules in terms of quality and in terms of geometry and even in terms of information requirements. And I started to develop these rules and to develop it with them. In a specific BIM use of quantity takeoff and cost estimation. So we have this specific use, and we started to derive the information requirements that we need for this specific use in order to implement the process. And using, as I said, level of information need, we started to categorize all these information requirements for 19 categories, mainly for the architectural and structural, using the standard framework of level of information need. And I derived this format from the standards and implemented through each category. And using regular expression, mainly for the naming convention, but also I used it for material list. I started to convert all the naming convention into a regular expression, which is a pattern used mainly for checking if the text is matching a specific format or not. And this is an example how you can convert it. And also it was converted for our family names and type names, and as I said, material list. And then I will show now how we can implement these rules and these regular expressions across each workflow. So the first workflow was done inside the repository, and here illustration how you can translate the rules. Mainly the focus will be some general checks and some geometrical checks and some alphanumerical information checks. And the powerful part here in this model configurator is you can edit it later in XML, or you can manipulate for faster creation. And model preparation will be inside Revit, and for the rule execution and reporting also inside the repository. And this is an illustration of how we can get the results. You can get here an example of the duplication elements. You can even get some results regarding some errors in the naming convention, or even some missing properties like the area. We are talking about quantity takeoff, and here some elements don't have the area property, which will lead later to wrong quantity takeoff. And here some general quality results, like some in-place families, which is not recommended by the company. The second workflow, which is done inside a standalone software. Here I use Solipri, and here we can see more functionalities in the Solipri software, because we can run checks regarding the architectural validation and clash detection parallel to the information requirements we already mentioned. And the same idea. We take these rules and interpret the rules using the functionalities of Solipri, and here is the results. We will find the results as illustrated, and each with different color with the ID, which we will use later for the PCF or the codes I mentioned to go back again to the repository. The third workflow using open BIM formats, and here in the rule interpretation phase, we can start to translate the rules into the IDS format. And for this translation, I used many tools. Like first, to initiate the base, I used the IDS converter, but it is somehow limited because you can only define one applicability and one requirement. But opening this on XML, which is somehow you can use the documentation and you can make it as complex as you can. Also, one tool to be mentioned, one of the akka tools, US BIM IDS editor. Also, it is useful because here you can get the rule in the IDS format, and it is also readable. So if you are not mature enough to use the IDS or in the elementary stage, you can use this tool. And for the rule execution, I used Blender BIM. It is open source, and you can use it. It is for free, and the idea is just to validate the IDS against the IFC. Also, I explored, as I said, like akka tools. They also have a validator tool, and the results, as we can see here, you can get the error and the ID of each element. So going to the fifth stage, which is like the automation of the results we already get. So whatever the workflow we are mentioning, we are getting specific issues with ID for each element, and then we need to navigate those issues to the repository. So the first code I developed using Dynamo was the main concept was to just classify all of these issues or all of these results together using a code that I developed or a keyword. So we can use this code, for example, which is the check code, and then we can get here like the elements that have the same error, and then we can isolate it inside the repository, or we can use a keyword, and then also we can isolate it and manipulate. We can build on this. We can delete the duplicated elements. We are here talking about the second scenario of geometrical duplication, or we can report it. Like we have those two options. You can only report to the BIM coordinator and then he take the decision, or you can delete it directly. And the idea is to compare. It is identical in terms of the geometry, and the idea is to compare if they are also identical in terms of the alphanumerical information, except for GUID. So if they are exactly the same, then one of them probably is copied by mistake, then you can delete it. If they are different in terms of the alphanumerical information, then it will be reported to the BIM model manager, and he can take a decision. And the third code I developed also using Dynamo was to manipulate with the results in terms of the alphanumerical information. You can here edit the value of the property, add a prefix or suffix. And then I conducted a SWOT analysis for each workflow to know the opportunities and limitations. Here we can see in workflow A, which is done inside the repository, there is no need to exchange. You can do all the process inside the repository, but in terms of the weaknesses, it is very limited for some functionalities. For instance, I would say for the clash detection, it is not the best option for this. For the workflow B, it is very, very powerful in terms of clash detection, as I mentioned, and even have some functionalities in terms of validation. We can mention here Solipri and Pixel. But the weakness is some of the softwares are not supporting regular expressions such as Solipri. And there is a threat of losing of information while the process of exporting from the repository to the IFC. And for the third workflow, it is very powerful. Here we are not limited to any kind of software. You can just develop the IDS separately and even in any XML editor. And then you can validate it also with any open BIM software. But the weakness is IDS cannot access the geometry, so it is only limited to the information requirements that is not geometrical. And here, as a general discussion and recommendation from the research, that we can integrate between all workflows together. So it is recommended to integrate between the three workflows together, depending on the project phase you are using and depending on your requirements. And here the key findings, I was able to use the level of information needed in a practical approach, and then we can see here how we can link it to the model checking processes. And also I showcase the powerful of using regular expression mainly in the naming convention checking, and also highlighted the using of IDS in the process, which is now somehow the standard way of the information requirement exchange. And this is some recommendation for the future research to focus more on the implementation of IDS and also focus on the geometrical representation adaptation. Thank you.